In Alice in Wonderland, Alice steps through the looking glass and discovers a world where nothing is quite as it seems, where a cat grins without a body, a caterpillar asks impossible questions, and a white rabbit leads you somewhere you never expected to go. In enterprise architecture, we have our own looking glass moment. We spent decades as the great and powerful Oz, hiding behind curtains, handing down edicts, enforcing standards nobody reads. But what if we became more like Alice, curious, enabling, building worlds where teams can explore and deliver with confidence? I'm Sean McCarthy, the Chief Archaeologist, and today I'm going to show you what happens when you stop being Oz and start being Alice, when governance becomes a product, not a gate. We're sitting at the looking glass. It's our urban planning dashboard. I've already initialized a mesh, which is just a lightweight YAML structure, organizes a portfolio into platforms, business applications. Think of platforms as city districts and business applications as the buildings within them. Right now, the application tab is empty. We have a city plan, but no buildings yet. Before we build anything, though, we need to understand what we're building and why. This is the enterprise architecture view. Business capabilities on the left, applications next to it, any policies that we have across architecture, risk, security, operations. The business information model and the data meta model, technology meta models and integration meta models. You can see under business capabilities, things are organized in the hierarchy, things like insurance operations, claims, L1 capabilities, and we go all the way down to L3 capabilities. The application view maps business applications back to those capabilities, but right now it's empty. So let's fix that. I'm creating a platform called IMDb Lite, simple movie database application. This is our city district. Every platform gets its own directory in the governance mesh with room for multiple business applications inside it. One application we have is IMDb Lite. This is the business application repository. This is the single source of truth for one application. It's architecture, it's security, it's risk, it's operations, threat models, reviews, everything about the application lives here. Rather than starting from scratch, I designed a very simple architecture for this. Here we've got the context view. This is how the outside world sees the system, the actors, the front ends, APIs, simple, clear, something that's easy to communicate. Logical gets down to more of a architecture view. You can see the API has a REST interface, databases has connections. We could click any of these nodes and see the properties of the object, the interfaces, the capabilities, the controls. These controls come straight from NIST. Things like the JWT bearer token issued by the API may need to be hashed with bcrypt with a cost factor of 12. Further down, we've got a list of architecture decision records. I pre-populate them, but let's look at one of them. Let's look at the MongoDB decision. We could see a nice title, whether or not the decision's been accepted, the context of the decision, the consequences, alternatives considered, any design characteristics around the reversibility of the decision, the cost of this decision, any related decisions that create a hierarchy of decisions. Think of almost like an ADR graph becoming a map of architectural intent. We also have an experimental feature, Epsilon. Epsilon isn't just asking questions. Epsilon helps us refine our answers and understands the architecture meta language natively and can propose changes to the architecture through conversation. We'll see a little bit of this once we start looking at design drift. Now let's navigate to the security pillar. We need to talk about threats. I published an article on security posture as a portfolio health metric. things like 90% vulnerability free as a target, but you can't fix what you haven't modeled. The security pillar allows us to generate a stride threat model directly from our column architecture. Threat model is generated from the architecture. It knows about every node, every relationship, every data flow, every control we've defined. And it has the results broken down by stride category. Spoofing, tampering, repudiation, information disclosure, denial of service, elevation or privilege. You can export the CSV as well, but we've already stored the JSON file as part of our business application repository, which is versioned. We also have a simplified threat model so that we can see visually where are what the attack surface looks like. Great. Now from here, the white rabbit appears. Always hurrying, always leading us somewhere new. We have an architecture, we have a threat model. It's time to turn that into a code. When I click implement based on this architecture, extension reads the column file, presents me with components I can implement. Here we have the column nodes for React front end, the movie API, the database, each one a potential repository. I'm going to pick the movie API. I'm an API guy. Repo name auto-populates. GitHub URL. Now I could go down the rabbit hole. Scaffold panel opens. This is where we're going to give our repository its SDLC skeleton. Target folder selected for me. I could change it. All of the great goodness. These defaults are already sensible. We need a MD file for the AI agents to understand the project. We need CI pipelines for our testing, a pull request template with security checklist. We need CoQL for static analysis, and quality gates. Think of this as the building's foundation. We don't want to build anything on top of a weak foundation. Otherwise, you'll be that building in San Francisco that's starting to lean over. We need this governance infrastructure in place. We select the language, the testing framework, the package manager. I do want to create the GitHub repository. And I do need to give it my Anthropic key if I decide to use Anthropic as the agent to do this work. So I'll scaffold. I'll give it the key. And now I can create the component feature. From here, you can see the features already selected for us. Remember is that we're going to do JavaScript with Mocha. We're going to build the movie API. But we want to put this into an RC-TRO format, a little bit more structured format to really get the best out of our agents. So I'm going to go ahead and generate the RCO-TRO prompt, pause the video, and when it's done, we'll come back. All right, here's the generated RCTRO. Role defines who the agent is, security engineer, bunch of information from our prompt. Context gives the architecture and constraints. Task is a specific implement the API, movie API service node, REST API, CRUD endpoints, RBAC, all that goodness. Requirements are very, very specific. It gets down to the MongoDB, the models, JWT authentication, RBACs, input validation, auth routes, CRUD routes, character management routes, and then a list of output files. These aren't vague instructions. They're structured, verifiable requirements derived from our column controls and threat model. I'm going to go ahead and accept it. I'm going to create the issue on GitHub. And now see the first of what could become many issues within this particular component repository. I can click on it, and I can assign it to Copilot to do the work for me. So I'm going to go ahead and do that. While that's running, we could go to the movie API. I just want to show you what's been created, right? So that's the scaffolding. We can look at the issue. If we look at the issue, we could see the fully formatted RCTRO prompt and one of our embedded prompt packs as well down here at the bottom, which gives the agent all of the information around our column. We want to review the control nodes that were attached, information about the OWASP top 10, security checklist to follow, threat modeling, build time controls, and then some code quality gates that we want to be considered. If we go back to our security dashboard now, this is the security dashboard in context with the movie API. Not much has been, we're not able to run much yet because it's in the process of working on that issue. From here, once we do get a package JSON file, we could do a refresh dependencies, which will do a minor upgrade across all the packages automatically. We could also click improve dependencies, which will then generate a new feature and ask any one of the agents to implement the breaking changes. Anything that's major will require some code refactoring and things like that. Once we have code, we can run code coverage. Any tests that don't have code coverage, we can improve coverage. Again, open up a new issue, again, in the RCTRO format, and then submit that to an agent to address those issues for us. We could do the same with technical debt in all of those types of things. So from here, I'm going to pause the recording until the feature is complete. All right, the White Rabbit has done its work. I ended up having to switch it over to the Claude workflow. Copilot just took forever to spin up code spaces to complete the work. But the PR was complete. Let's take a quick look at what it did. We can kind of go back to the issue. It is closed now. You can see the prompt. You can see we're messed around with Copilot. Here, Claude did the implementation plan. Pretty robust. Put it into 14 phases. Created a good mapping between the files and Stride and OWASP, which is awesome. 54 files. Updated things from the scaffolding. Here's the implementation. It went through all of the phases, committed it, summarized all of the things. So it implemented the security controls, 95 tests pass, unit tests for auth middleware, RBAC validators, log security events, integration tests. Remediation was complete. We did the pull request. We merged it. I now need to, I got the indicator within the security dashboard that we're out of sync. So we're going to pull down the changes and we can see some things have happened. We've got a lot of code now. You can see all of the architecture, automation, source, all of our utilities, routes, models, all of our tests. We did introduce, it looks like 11 vulnerabilities. So we could go to the security tab and kind of see what happened. So we got some database queries that we're going to have to address, and we can certainly assign all of these because what will end up happening with the workflow is these high vulnerabilities will get turned into issues as soon as the actions kick off. So CodeQL to security issues will implement new issues that we can then start going through and implementing. Okay, we could run coverage and see if we've got good code coverage, and again, improve the coverage if we wanted. So it's good. So, the security scorecard is tracking everything. It detected the open issue, the CI status. Now that it's merged, we sync the repo and the scorecard refreshes. And we've always got an up-to-date kind of health score, security findings, dependency status, and all of those metrics I talked about earlier, right? Release quality, security posture, technical foundation. This is really where the portfolio health metrics come alive. C grade's not too bad. Before this, I was getting some D's and F's. So overall, we've got good guardrails with CodeQL. Any vulnerabilities detected will show up. And this is the powerful part. Every finding here is actionable. I can click any one of these and create a GitHub issue, and the same RC, RTO pipeline will follow. We'll just fire off, and I can assign it to an agent, and the governance loop will continue. Or I could create a new feature and do something new, maybe a new capability, those types of things. So let's switch back, actually, now that we got this pretty well defined architecture. We'll remediate those things after we take a quick back look at the business application repository. So now we've got one of the implementations done. So let's go ahead and kick off a review. I'm only going to do the architecture one against this repository. Submit the review. This one I should be able to give to Copilot because it's less complicated. See, Copilot is reviewing this application. So what it's going to do, it's going to take all of the artifacts from our business application repository, and then it's going to compare it against the actual code that's in any of the linked repositories. Now I should get one finding that we don't have an implementation for the React front end, but we'll see how much other drift things occur. Okay, looks like we've got an issue, we've got a PR. The Oraculum is really our architecture review agent, named after the Caterpillar's Oracle. It reads this column architecture, checks actually been implemented, and tell us where the gaps are. That review probably took about 5 minutes. And now we gotta review it and merge it, confirm the merge. This will pull down the results. You can kind of see what it did. Did an architecture review, created a review, added a record so that we can look at the drift score, and then it gives us a kind of high-level summary of the different highlights and things like that. Because we did the merge, our issue is auto-closed. We could go ahead and pull it because we're 3 commits behind remote. You could see we got a score of 39, pretty high drift. We could go ahead and click the top hat to summarize the findings. And as expected, the React front-end service is absent from the reviewed repository scope, and the email service integration is missing from the code base. Our Stride threat model is empty, security controls and compliance are unpopulated, data classification matrix unpopulated. So these are some things that are also missing within our actual bar files. Deployment pipeline YAMLs missing from the repository and those types of things. And we don't have an operations runbook yet. So that's good. We've got some good information. And, if we run a review, we'll start to get things like a spark line that will show up under here to how well we're kind of improving the overall governance of our application and things like that. Really, this is evolutionary architecture in practice, not a point in time review that gets filed and forgotten. Continuous validation, architecture is alive, Caterpillar is always watching, drift is measured, not as a punishment, but as a backlog. And these gaps become the next items that the White Rabbit will lead us to implement. So let's take a step back maybe from this rabbit hole. And what did we do in roughly 30 minutes? Would have taken weeks in a traditional enterprise architecture practice. We defined a business capability model. We created a column architecture with type controls on the boundaries. We generated a stride threat model. We recorded architecture decisions, scaffolded a secure project with CI/CD and quality gates baked in, wrote a structured implementation specification with traceable requirements. We assigned it to an agent, reviewed, merged the code, used automated quality gates to identify what's missing, and ran a design review that told us exactly where to go next. Every step was governed, every decision recorded, every control traceable from architecture to code. The CIO article, from projects to product, it's really talking about this shift from this Oz mindset to the Alice mindset, from control to enablement. This is what enablement looks like. Platforms and guardrails that make doing the right thing easy, not gates that slow you down, but rails that keep you moving in the right direction. And the Cheshire Cat's smiling because he knows something we're just starting to understand. In a world of AI-assisted engineering, governance isn't the enemy of speed. It's the source of it. Thank you.